Okay, so we're on section 2.2, the classification of matter, and we're going to go ahead and skip the warm-up. And we're going to come down here to classifying matter. And everything in the world is either a form of energy or a form of matter. So previously we talked about things that are matter. Remember, matter, that's a little too thin, let's make that thicker. Matter is anything that occupies space and has mass. And then I mentioned to you some things that are not matter. Those are things like light, which happens to be a form of energy, and sound, also a form of energy. And then there was one more, if you can think about what that was, that we listed in the previous section. There are different ways to classify matter, and one of the most common ways is a flowchart that looks like this. So you're either going to have something that's pure, so when it's a pure substance, it's going to look the same no matter where you are in the sample, and then you might have a mixture. Pure substances can be one of two things. They could either be an element, which is anything from the periodic table, so that could be copper, which has a symbol of Cu. It could be silver, which is Ag. It could be hydrogen. It could be chlorine, as long as it's just one of the elements alone from the periodic table. And then we could also have something that's called a compound. Now, in order to form a compound, you have to have two different elements chemically combining, sometimes three, and we'll go over that later. But if you have something like table salt would be something like NaCl, which is called sodium chloride. So what they did was they chemically attached sodium and chlorine to each other, and they made table salt, which is a compound. So in order to convert from elements to compounds, a chemical process has to take place. And then if you're going to convert a compound into an element, that would be a decomposition, another chemical process that has to take place and just in order to separate it from each other, okay? Now, if we take a look at the table here, the table goes over some more details about these things. So if you take a look at a pure substance first, anytime you're looking at a pure substance, there will be one set of properties. That means there would be like one melting point, one boiling point, one density, okay? And then if you take a look at a mixture, mixture is going to have different components combined. They may not be in the same quantities, and each one of those individual substances that's in that mixture is going to retain its own identity. So it would still have its own unique color, state of matter, density, melting point, boiling point, etc. Okay? And then if you're taking a look at something like an element, which we talked about a little bit up above, that would be a pure substance. You cannot decompose an element into simpler things because it is only made of one type of atom. Maybe it's a chlorine atom, maybe it's just a hydrogen atom, maybe it's just a carbon atom. And then compounds can be decomposed because those have more than one type of atom, and those are chemically attached to each other. So if you're taking a look at a picture, an element would be something like, if I have the same looking substance throughout that entire sample, that would be an element, okay? Compounds would be chemically attached. So if I have something like this would be an example of a compound because those would be two different types of atoms chemically attached to each other, okay? And then pure substances, I'm going to divide this box in half. A pure substance would either be an element, like here is an example of an element here, but you could also have a compound as long as the entire sample was the same compound. And then mixtures are just, a bunch of things combined together. If you think of like a pepperoni pizza, for instance, if you had, let's say, something like this, I have an element and I have a compound combined together, you could say that that's a mixture. Okay. Let's take a look at the next page. Anytime we're talking about the different particles that are involved in matter, we may call them a chemical species, or we may just call them a species. Okay, so the word species is something that we use to refer to things like atoms, molecules, or ions. Okay? All right, let's take a look at the next part. Let's talk about elements exclusively. So I gave you a periodic table, and that periodic table is divided up into 3 different types of elements. You're going to have metals. Metals are on the left-hand side of the periodic table. Metalloids fall along the darkened stair step. We'll go over those in a second. And then the last type would be nonmetals, which are on the right-hand side, except for hydrogen, which you'll notice happens to be in the upper left and the upper right-hand corner, which I'll go over that in a little bit more detail later on. Okay. Some of the columns that these elements exist in have specific names. For instance, you'll see the first column on the left-hand side, this is group 1. These are called the alkali metals, okay? And then you have the next column, this is group 2. These are called the alkaline earth metals. Those are the only groups that have specific names on the left-hand side of the periodic table. And then on the right-hand side of the periodic table, we have a group called the halogens and a group called the noble gases. So the current numbering system for the periodic table has a 17 above the halogens, and then there is an 18 above the noble gases. Okay, all of the other groups are just referred to by number 1 through 18. There's a new numbering system and an old numbering system, and I'll go over that in a little bit. What's important to know is that 80% of the elements on the periodic table are metals, and the metals are separated from the nonmetals on the periodic table by the staircase that consists of the metalloids. So let me pull this down and show you what I'm talking about. So on your periodic table, on the right-hand side, you've got this darkened stair step. And all of these right here are where my metalloids fall. So all of these elements that are shaded in this purpley pinkish color, you should color code these in a certain color. You pick it, and you should make a key that these are the metalloids. Okay, you're going to want to memorize the name and the symbol. I will definitely ask you about those later, okay? And then what you want to do is pick a different color, and you want to color in your nonmetals in that different color. So for instance, everything to the right of the metalloids would be considered a nonmetal. So all of these elements here, and this is just a brief, like a cutout of part of your periodic table, but you would color all of the elements to the right in that different color, and then pick another color, and everything to the left of the metalloids, you should color them a third color, and this would include the detached rows that are underneath here. Those elements are also metals as well. It says right here, these are all of your metals. So make yourself a key off to the side, which ones are the metals, nonmetals, and metalloids based upon color, because you're going to build upon this once we get into later sections, okay? Now, what I'm going to do is I'm going to pull up the periodic table that I gave you. So let me make this a little bit smaller. We're going to go over to Canvas. And if you lose the periodic table that I give you, you can always print it out. So this would be under Chapter 2. And then you would scroll down to section 2.4. And then you want, I believe, this one that's outlined in pink right here. This is the one that you want to look at. I downloaded it already. Here we go. Okay, so here's the one that I gave you. Okay, so just to make sure you understand that you need to color the metalloids, non-metals, and metals. So your metals are all over here, excluding hydrogen. So what I'm going to do is make a note that this is a non-metal. I'll explain why it is on the left and the right-hand side later. And then you have all of your other non-metals over here. And then you should have taken a different color for your metalloids within here and color coded them as well. And then just so that there's no confusion, these two rows that are detached down here, these are also metals as well. So I would color those the same color as your metals, okay? Now, I'm gonna go back to the book. And the reason why you see hydrogen on the left and the right side is because hydrogen is actually a unique element. It technically has a positive and a negative charge, which we'll talk about later, but it's kind of considered to be in a group of its own. It has some properties of metals, but it has more in common with the non-metals, hence the reason we tend to refer to it as a non-metal, okay? All right, let's go to the next page. On this page, they give you the properties of metals and nonmetals. For instance, metals are great conductors of heat and electricity. They're malleable, which means I can pound them into thin sheets. You absolutely need to know this definition. They're also ductile, which means I can draw them into thin wires. You also need to know the definition of ductile. And they have a pretty metallic luster. A lot of people think that metals are hard. That is a misconception. Okay. Alloys, which are mixtures that contain metals, those are always hard. Okay. So, and then lastly, there is a chemical reaction that's common for compounds that contain metals with oxygen. So these are called metal oxides. They react with water and they form a base. And bases contain a hydroxide, which I'll talk about later. So everything that's here, these would be properties of metals, okay? Here is my metal oxide. This is sodium oxide. Sodium is on the left-hand side of the periodic table. It reacts with your water, and you're forming a base. So this is my base, and the reason it's a base is because it contains an OH in it, and the OH is my hydroxide, okay? Next, we have properties of nonmetals. Nonmetals are terrible conductors of heat and electricity. If you take a look at the periodic table on the wall, you'll notice that the periodic table on the wall has got different colors for the symbols. A lot of the nonmetals are gases at room temperature. How do I know that? That's because they are red symbols on the periodic table on the wall. And then some of them are solids. The solids tend to be black symbols. And they're brittle, and they shatter easily when they're nonmetals. A common reaction for nonmetals with oxygen would be a nonmetal oxide will react with water. It'll form an acid. So here is your nonmetal oxide because carbon is on the right-hand side. It's a nonmetal combining with water to make an acid. Acids tend to begin with a hydrogen ion, and this is called carbonic acid, okay? Then we have a trend for the first trend that you guys are going to learn for the periodic table. The first trend is for metallic character. Metallic character increases to the left and down on the periodic table. So if this is your periodic table, that's the general direction. Make sure you memorize it. And that's because you're moving towards the metals. So metallic character would be increasing, okay? Something else that you should know is that some elements on the periodic table have allotropes. Let me stop this video and restart it.